Hello students. So today in this video, we're going to start with a new chapter, that is quadratic equations. So we're going to start with quadratic equations. A very important chapter and an easy chapter also. So before getting into what are quadratic equations, let's learn some basic things. Let's say yeah. Let's learn these important things known as variables, constants, algebraic expression, and the meaning of equation. Then we'll get into quadratic equation. So what are variables? As you can see, symbols whose values are not fixed. Okay. Let's say English alphabets, X, Y, Z, all these values are not fixed, right? The X might be 5 for me or 3 for someone else, -2 for someone else. It is not fixed. It keeps changing from person to person. But whereas constant, those values are fixed. For example, pi. Pi value is 22/7, isn't it? Pi value is actually an irrational number, but we take it as 22/7 for calculation purpose. So the pi value 22/7 is same for everyone, isn't it? It doesn't change from person to person. Similarly, the number 5, its value is 5, right? It doesn't change, isn't it? So basically the numbers are constants and the alphabets are variables. Now, what is algebraic expression or mathematical expression? It is simply the combination of variables and constants. How do you combine them? Using plus sign, minus sign, or division sign. Okay. So for example, as you can see here, we have got 5 plus x. So 5 is a constant, x is a variable. We have combined using plus sign, or x square minus y square, x cubed by 5, 5 into y square. All these are algebraic expressions because we have combined constants and variables, or it might be variables and variables itself. Okay, it might be combination of variables and variables, or constant and constant, or constant and variable, anything. On the whole, it is combination of something. Okay, using plus, minus, or division sign. So these things are known as algebraic expression. And if this algebraic expression is equated to 0, it need not be 0, it can be anything. If it is equated to something, then we call that as an equation. So what is an equation? An algebraic expression equated to 0. Okay. But if you observe in the second example, I have equated to 25, isn't it? X square minus y square is equal to 25. But if you get this 25 to other side, so it becomes 0, right? So it is like equating to 0 itself. So doesn't matter x square minus y square. Doesn't matter what we equate, we have to equate it to something. So this is known as equation. So we know what is an equation. Basically, equation is an expression, a mathematical expression in which it is equated to something. So what is a quadratic equation? It is also an expression. It is also a expression which is equated to something. Okay. So let's get into quadratic equation. So it is an expression, okay, or an equation of the form, or you can also say quadratic equation is a polynomial, quadratic polynomial equated to 0. Okay, what is a polynomial? We'll be discussing polynomials also. There is a chapter polynomials itself. What is a polynomial? It is an expression. It is an expression in which the powers are whole numbers. The powers are only whole numbers. That is, you cannot have negative, you cannot have fractions. For example, x to the power of 2 plus 5x plus x to the power of 1/3 is equal to, or let's not equate it. See, this is an expression, isn't it? But is this a polynomial? No, it is not a polynomial, because if you observe, the variable x power is 1/3, which does not come in whole numbers, isn't it? So this cannot be a polynomial. Or let's take an example, root x plus 2. Root x in index form can be written as x to the power of 1/2, isn't it? So plus 2. Again, here the power is a fraction, so it cannot be a polynomial. Or let's take x plus 1/x. Usually all the variables must be in the numerator. So 1 by x, if you write it in the numerator, it will be in the form x to the power minus 1. So here minus 1 is a negative number which doesn't come in whole numbers. Okay. Therefore, I can say this example x cube plus 5x square plus 2 is a polynomial, isn't it? Because all the powers are whole numbers. Okay. So quadratic equation is a polynomial, is a quadratic polynomial which is equated to 0. You can also define like that. Okay. So let's write all the different types of definitions. The basic one that I can write here is a quadratic polynomial equated to 0. What is quadratic equation? Definition 1. Okay. So definition 1, I can say a quadratic polynomial equated to 0. A simple definition. Or the second definition, an equation of the form ax square plus bx plus c equal to 0. Okay, this is a quadratic equation. Why? Because the degree is 2. If the highest power of x is 2, then we call it as quadratic. That's it. Okay, here variable is x and the highest power of x is 2. Therefore, it is called as quadratic. So an equation of the form ax square plus bx plus c equal to 0. What are this a, b, c? Where a, comma b and c are real constants, meaning you can give any value to a, b, c, but for a you cannot give 0. Okay, because if you give a as 0, 0 into x square will become 0. This entire thing will vanish if you give a as 0. Then what is the highest power of x now? It is 1. So it will become linear equation. Okay, it doesn't become quadratic equation. Okay, so if it has to be quadratic, the a value should not be 0. Other than 0, you can give anything you wish. Okay, here b can be 0, c can be 0, no problem. Because even if b becomes 0 and c becomes 0, the degree of x, that is the highest power of x, doesn't change. Okay, so a value should not be 0, but b value, c value can be 0. So an equation of the form ax square plus bx plus c equal to 0 is known as quadratic equation. Okay, let's see some examples. Few examples. X square plus 5x is equal to 0. Is a quadratic equation. X square minus 25 is a quadratic equation. Okay, if I don't equate it to 0, then it becomes quadratic polynomial. That's it. Okay, it is a quadratic polynomial. If I equate it to something, in particular, if I equate it to 0, it becomes equation. Okay, or let's take x square plus 3x plus 6 equal to 0. All these are quadratic equations. Okay, x square minus 9x, or let's take 5x square minus 9x plus 10 equal to 0. All these are the examples for quadratic equation. Okay, so now we have seen certain examples also. Okay, now why do we need this quadratic equation, or where do we apply this? If you remember in your 9th standard, okay, let me draw it properly. If you remember, there were 3 equations of motion. 3 equations of motion. That is, if an object is traveling in a straight line, okay, if an object is traveling in a straight line, then you had 3 equations of motion. One was v equals u plus at and s equals ut plus half at square, and the other one was v square equals u square plus 2as, isn't it? In this, the second example and the third example are actually quadratic equations. Okay. If you consider t in the second example, what is the highest power of t? The highest power of t is 2, which means the degree is 2. So this is a quadratic equation. So this quadratic equation helps us to find the acceleration or displacement or the time, isn't it? So what do you have in this equation? We have s, which is displacement. We have u, which is initial velocity. T is time taken, a is acceleration, and t is time again. So using this equation, quadratic equation, you can find the value of the time, isn't it? If an object is traveling in a straight line, you can find the time if you know the displacement and acceleration. Similarly, in the third equation, v square is equal to u square plus 2as. This is also a quadratic equation. If you observe, the highest power of v is also 2 and the highest power of u is also 2. Okay. So both the highest power of the variables itself is 2. Therefore, this is a quadratic equation. Here also you can find the value of initial velocity or final velocity. All these are quadratic equations, isn't it? So using quadratic equations, one beautiful application is you can find the time taken by an object in traveling in a straight line, or the acceleration, or the final velocity, or initial velocity. You can find the velocity of an object, or time taken by an object, or the displacement of object traveling in a straight line. This is one such. Or let's say another important application is, see, suppose you're standing a point on the ground. Let's say you're standing here. Okay, you're standing here and you're throwing a stone upwards. Okay, let's say you throw the stone upwards. Does it come back in the same manner in the straight, in a vertical direction? No, right? If you throw it, it will go to a topmost height based on your speed that you have thrown, and it comes back. Okay, if you observe the pattern, it goes something like this and comes back. Okay, this is known as a parabola. The figure that I've drawn is known as a parabola. Okay, parabola, if you observe, if I've thrown here, if this is the point that I've thrown, the stone will reach somewhere here. Okay, now at what distance, what will be the distance between the stone and the person? Okay, that can be calculated using a quadratic equation. Or the maximum height that it has touched, that can be calculated using the quadratic equation. Okay, basically parabola itself is a quadratic. Okay, the equation of the parabola will be actually like this: x square is equal to 4ay, or y square is equal to 4ax. If you observe, the highest power of y is 2, isn't it? Or another important application that I can say is, see, there is an aircraft, or let's say there is some flood in some place. Okay, let's say there is a flood. Okay, let's say there is some flood. Okay, I'm just taking this to be an aeroplane. Now this is the region, below it there is some flood. Okay, now this aeroplane is carrying some food and medicines. Okay, now let's say people are here. Okay, we have got people here. Now this aeroplane has to drop the food and medicine. Now if it is exactly on top of them, if it is exactly on top of them, and if it drops, okay, and if it drops, will it come vertically to them? No, definitely no, because it will trace a path something like this. Okay, due to other external factors, the package containing the food and medicine will contain something like this. So the person should get to know at which point in the air should he release the food and medicine, so that somewhere if he release, so that the packet will reach them perfectly. Okay, if he reaches at this point, it will not come like this directly. Instead, it will go something like this. Okay, therefore not reaching the person, isn't it? The same techniques are used in dropping the bombs, okay, on a nation or something, okay, which is a negative effect. Let's not discuss that. Let's use it for some emergency purpose like this. Okay, so quadratic equation has many applications. Okay, Now, in your textbook, the first exercise, we have to find whether the given equations are quadratic or not. Okay. A very simple one. An equation is said to be quadratic if the highest power of the variables are 2. That's it. If the highest powers of variable are not 2, then it is not quadratic. As simple as that. Okay. So let's see the first exercise. So the first exercise, check whether the following are quadratic equations. Okay. So the first one is x plus 1 the whole square is equal to 2x minus 3. Okay. Let me pause it and let me copy all the questions so that it will be easy to discuss. Okay. So we have all the questions here. Let's solve one by one. The first one is x plus 1 the whole square is equal to 2 times x minus 3. Okay. Let's simplify it first. Okay, let's simplify it, then let's come to the conclusion. Okay, x plus 1 the whole square is in the form of a plus b the whole square. So a value is x and b value is 1. So a square plus b square plus 2ab is equal to, in the RHS, let's use a distributive property. That is 2 should be multiplied for both. 2 into x, 2x minus 2 3s are 6. Okay. So x square plus 1 square is 1. 2 into x into 1 is 2x. Again equals 2x minus 6. Now if you observe in the left hand side and the right hand side, both the sides you got 2x. So let me cancel it. So what is it that you are left with? X square plus 1 equal to minus 6. Let's not further simplify it. This is enough. Is there any chance that the power of the x will reduce? No, right? It's not possible. And the next step that you will do is you will get 6 to the other side. So it will become x square plus 1 plus 6 equal to 0. Therefore, you get x square plus 7 is equal to 0. What is the highest power of the x? The highest power of x is 2. That is, the degree is 2. Therefore, it is quadratic equation. So let's get into the next one. Let me draw a line. Okay. The second question. The second question is x square minus 2x equals minus 2 into 3 minus x. Let's simplify it, then let's come to the conclusion. X square minus 2x is equal to minus 2 into 3 is minus 6, minus into minus is plus, 2 into x is 2x. Okay, isn't it? So I'm sorry, minus 2 into 3 minus x. So if you simplify, get all the right hand side terms to the left hand side, x square minus 2x minus 6 to the other side will become plus 6, plus 2x to the other side will become minus 2x equal to 0. Therefore, it will become x square minus 2x will give you minus 4x plus 6 equal to 0. Again, this is a quadratic equation because the highest power or the degree is 2. Therefore, since the degree is 2, we can tell that it is a quadratic equation. Okay, let's get into the third one. The third one is x minus 2 into x plus 1. X minus 2 into x plus 1 equals x minus 1 into x plus 3. Okay, here we have to use the distributive property. That is, this x should be multiplied to x and to 1. Similarly, minus 2 should be multiplied to x and to 1. Okay, the same pattern here. X to x, first into first, first into second, second into first, second into second. Okay, we have to multiply like that. So let's multiply that. So what do we get? X into x is x square, x into 1 is 1x. Next, from minus 2 into x is minus 2x, minus 2 into 1 is minus 2 equals, again, x into x is x square, x into 3 is 3x. Minus 1 into x is minus 1x, minus 1 into 3 is minus 3. Now, if you observe, or let me simplify, x square plus 1x minus 2x is minus 1x minus 2 equals x square, 3x minus 1x is 2x minus 3. Now, if you observe both the sides, LHS and RHS, you got positive x square, therefore you can cancel it. Therefore, you are left with minus 1x minus 2 equals 2x minus 3. Get everything to the LHS, minus 1x minus 2 minus 2x plus 3 equal to 0. Therefore, you get minus 1x minus 2x is minus 3x, minus 2 plus 3 is plus 1 equal to 0. Now, after simplification, what is the highest power? The highest power turns out to be 1, isn't it? The highest power of x or the degree of x is 1. Therefore, this is not a quadratic. Third one is not a quadratic. Okay. Similarly, let's give it, you can take this as a task and you can find it. Okay. So I have done 3 problems, 4th one, 5th one, 6th one, 7th and 8th. You can take it as a task and you can try it out. Okay. Thank you, students. In the next video, we'll continue with the other important concept of this chapter. Thank you.